Okay guys, so what we're looking at here is a graph where area and length, and we're comparing. So if I asked you what was the vertex of this, you're going to say, well, Dr. Spears, I know the vertex is right there, okay? The vertex is the highest point of this graph. So my vertex is clearly 2,800, okay? If I asked you what the x-intercepts are, you would say, well, Dr. Spears, the x-intercepts are right there. So I have an x-intercept at 0, 0, and I have an x-intercept at 40, 0, okay? So those are my two x-intercepts, that's my vertex. So we know we could go ahead and write an equation with this information. Okay, so I know the vertex and I know a point, so I know my x-intercept. So I'm going to use the lovely formula that we talked about in class, which is the y equals a parentheses x minus h squared plus k. And I'm simply going to plug in the values that you see up here. Okay, so I'm going to plug in, I know my y is 0. I don't know my a, I've got to solve for that. I know my x is 0. I know my h is 20 squared. And I know my k is 800. So I'm going to go ahead and run this problem through. And when I do, I end up with a equals -2. Okay, so once I do that, now I can set it up and plug it into the form back here. So I have y equals -2 x minus 20 squared plus 800. And there I have it set in the vertex form of my parabola, my quadratic equation. So this right here is just labeling everything, the graph of a parabola, telling you where the axis symmetry, where the x-intercepts, and where the vertex and y-intercept are located. All right, and here's just another illustration where you see now, because we talked about it, another word for the x-intercepts is root. So they could be roots, they could be zeros, they could be x-intercepts. And again, they show you where the vertex is, so you get just another illustration.